Chapter 10.3, Experimental Probability. So in Chapter 10.2, we looked at probability, mathematical probability. For example, we said that the probability of getting tails when I flip a coin is 1/2. Okay? This is the mathematical probability. If everything was even, my probability would be 1/2, meaning if I flipped the coin 20 times, 10 would be, of the 20 would be tails, and 10 of the 20 would be heads in mathematical probability. But today, we're going to be looking at experimental probability. Sometimes probability is difficult to determine based upon some sort of mathematical formula, heads or tails. I only have those two options, particularly when talking about sports. Sports in particular is based on experimental probability. We use this to predict the likeliness that an event will occur based on how many times it has occurred in the past. So the probability of an event happening is the number of times an event occurs over the total number of trials. So, for example, let's go back to this coin for a minute. Let's say that I flip that coin 20 times again, and I record how many times heads shows up, but in my experiment, I only get, let's say, 7 heads. The experimental probability of that experiment would be 7/20, not 1/2. It's relatively close to the mathematical probability, but the experimental probability is exactly what occurred when I actually flipped the coin. So let's take a look here at example 1. In 20 tennis matches against Jenny, Eileen wins 9 times. What is the experimental probability that Eileen wins a match? So based upon the 20 games that they have already played, Eileen wins 9 of them. This tells me that if she continues to perform at that same level, that if she played another 20 matches, she would win 9 of those also. It's one way that we can kind of predict future behavior. But for this experiment, or this event that happens, out of 20 matches, she wins 9. So the experimental probability that she wins is 9/20. Now, the complement of that, the probability of her losing is 11/20, because if she didn't win, she lost. All right, let's take a look at example 2. So you and your friends want to play a fair game, but your only number cube is chipped. To make a fair game, you roll the number cube 60 times. The results are shown in the table. So 16 times they rolled a 1, 17 times they rolled a 2, 12 times they rolled a 3, 8 times they rolled a 4, 4 times they rolled a 5, and 3 times they rolled a 6. So this was a total of 60 rolls. Okay? So problem A, which of the following games seems fair and why? So A, you win if the number rolled is 6. Your friend wins if the number rolled is 2. Well, if you think about a number cube mathematically, the probability of getting a 2 equals 1/6, and the probability of rolling a 6 also equals 1/6. So mathematically, this would seem fair. But let's take a look at what they actually rolled. So what they actually rolled, the probability of rolling the 2, experimental probability, was 17 times out of the 60 rolls. the probability of getting the 6 was only 3 times out of the 60. Well, that's a big difference. So I would say that no, this one was not fair. And it was not fair because the probability of rolling a 2 was much higher than the probability of rolling the 6. So let's take a look at B. If the number rolled is even, you win. If it is odd, you win, or your friend wins. Okay, so mathematically, there are 3 even numbers and 3 odd numbers, so your chances would be the same, 50-50. But let's take a look at our evens and our odds. So the probability of an even is 17 plus 8 plus 3, which equals 28 out of a total of 60 chances. Okay, just about half, only 2 away from half. So the probability then of rolling an odd are all of the other numbers, which would be 32 over 60. And I know that because I know that the 28 and the 32 have to equal 60 because I'm taking into account all of my numbers now, all of the evens and all of the odds. So I would say that yes, this is fair. While your friend has a very slight advantage, both of you have about a 50-50 chance of winning. Okay, that's it for examples. Complete your QCs and CYUs, and if you have questions, I will answer them in the morning.